everyone, my name is Georgi and I'm DevOps engineer. Currently, I'm responsible for one huge Kubernetes infrastructure in multiple environments. And previous week, we had to upgrade it to EKS Managed Cluster version 22, along with the Terraform upgrade module of the EKS to version 18 where there were a lot of breaking changes and honestly it was really tough task, so I would like to share my experience with you because I put an eye on the YouTube channels and videos and I was unable to find existing one, especially when uh, the entire process is managed through Terraform, which adds additional complexity to the task. uh, Also, next week I have to take a speech on that topic, so this is more like an exercise for me and my speech. Um, so it's really a long speech and a lot of things that I can and would like to mention, but uh, so I don't want to bothering you a lot. This would be the first part, and if you have an interest, I will share the second part next week. Um, so the official guide, if you follow it, the procedure is to use Terraform state move commands because due to the a lot of breaking changes, the entire cluster and the main cluster resource of Terraform is recreating, and a lot of people are trying to avoid that. But if you are if you are using release process through continuous integration and continuous delivery, it's a little bit hard to follow this. So we decided to take the approach to completely destroy our cluster and create it again. Uh, yep, here is the funny part. Um, we prepared the pull request within a week because a lot of resources are renamed, another one are removed, so you have to rename the renamed resource and to replace the removed one with the new solutions, which sounds easy, but for some of them it's not so. Um, and our idea was to make everything in one pull request to release that version and everything to be fine. But first issue we hit is that you can't do that without renaming the cluster because the native behavior of the cluster resource is cluster before create before destroy of the cluster resource, which means that a new cluster would be created with the same name and the old one would be destroyed then. But if you don't rename the cluster, another cluster with the same name will be created and pipeline will fail because this cluster name already exists. Um, we we didn't want to rename the cluster because we don't know if there is some hard coding of the name, although we are using Terraform state for that everywhere. So we started digging into the module and to check where this is set, the create before destroy, and to remove it. Actually, we found that there is no create before destroy on the main cluster resource, but we have a lot of depends on another resources, and the native way of working of Terraform and the lifecycle create before destroy is where you have depends on some resource that has a life cycle, and hence the cluster resource which has depends on automatically inherits the create before destroy. So we try to comment out in the model the entire part, but because you violate the sequence, it was impossible for us to do that. So we decided to create one version for destroying, completely destroying, and another version that will create the cluster on the second part. And here is the second point, how to properly destroy the cluster in the first version. So we've done some mistakes first time, and the best way we found it was that to comment out the the other code that is outside of the EKS cluster, and to leave only the module and the mandatory part. Also setting the module create cluster set to false, which is coming from the module. So in this way, we does not remove the code, but it know what to do through that variable set to false. Along with the code removals, you have to remove the OIDC provider and the outputs that are referencing it. So I think there should be not much problems on that part. Uh, but the more problems came to the second part where we had to create the cluster. It really depends on how your configuration is, what level of access you have in your CI/CD, and how much stages you have in your pipelines, because our infrastructure is with multi-stages, and that added some complexity because some of the code was not on the right place. And I will not go so in depth, but would mention the most critical part that you may encounter. Uh, so let's see. I took some notes. Yep, I'm already mentioned the cluster before destroy. Uh, okay, so we experienced an issue after creating the cluster that a new security group was created on the worker nodes from the cluster, but we didn't want to do that because we are managing our security groups by ourselves. And this is better approach because now there are changes to the cluster group that are coming from the module, and the network traffic is much restricted. So if you rely on that, you have more problems. But we know exactly where our traffic is going and what to allow and what to restrict. So the problem we had is that these security groups were conflicting and some of the rules were trying to duplicate. So what we wanted to do is to say to the Terraform module, do not create the native security group and leave that behavior to be managed by ourselves. So we had to set on the self-managed node groups because we were using self-managed node groups instead of a managed node groups one. The variables that are managing the security group. I don't remember them now, but you can see it first if you look at the module and look for security group, and second if you look at the documentation. Although if you experience some issue, just put a comment and I'll help with that. But the important part is that we had to set that on the self-managed node groups instead of the EKS module only. So here is something else regarding to the security group, because if one security group is attached, you can't remove it through the CI/CD because it's already attached and the CI/CD hangs. So the only thing that you will see is how the process is going and going and going, but nothing happens. And that's a real issue when you are using CI/CD. And that was one of the reasons we don't want the module to manage our security groups. If you are managing security rules and removing only the rules, there is no issue. But this issue is often happened in these environments, and you have to bear that in mind. One more thing is that the second main problem was the authentication problem in the cluster. I mean, with the Kubernetes provider, the AWS CLI, and the kubeconfig. So, because lot of things are deprecated and removed. For example, the old way of managing kubeconfig was deprecated, and we had to create a new resource in our Terraform where we are executing AWS CLI command, update kubeconfig, which is updating the kubeconfig, and everywhere you are referencing the old module, you have to reference the new resource module where you are managing that yourself. Of course, there may be another solution. That's our one that I share with you. And what we saw is that uh, configuring exec plugin in the Kubernetes provider is mandatory, but don't use data resources for fetching cluster names because that's an issue. And a lot of people mentioned that in the GitHub pages. We took another approach and actually we tested multiple solutions. Uh, Fetching the name from the state was a good one, but it's not a good one if you want to use that code to create a new cluster because when you create a new cluster, you don't have the name in the state. So we are looking for the best solution that is creating idempotent infrastructure, and most of the people always repeat how they have idempotent infrastructure, and when you run the same code the result is the same. But scenarios like that prove us that these scenarios should be tested more often because they prove this is not exactly like that. uh, You can also use local resources for fetching the name in the Kubernetes provider, but this is something that you have to bear in mind. You have to properly configure your map rows so you handle the authentication issues uh, like it should be. Uh, Actually, the old method was deprecated, and I found that some people created a new old module that is responsible for the map rows. But we decided to create our own solution also for that, not only for the kubeconfig. So there was no a huge difference between uh, the two map row managing approaches, but the main part was, and what we found and debug is when exactly the row mapping is creating and on what stage. So our cluster have to be created before this happens. But in in the moment we experienced the issue, it was in a reverse way, and that was our huge biggest problem because we also had the solutions on the EKS stage where they are losing the authentication and they can't be removed. They can be stopped, they can be commented out, and nothing else. And you are blocked. So we first move them outside of the cluster, where our cluster is only the cluster resources. So we cleared a lot of things that previous people managing the infrastructure was doing, and we are very satisfied with that. I already mentioned that. Yeah, when you create the new resource with the AWS CLI update, you have to bear in mind what version of AWS CLI in your CI/CD process you are using, because kubeconfig contains one API version, and if you are using older version, you can end with API version v1 alpha 1, which will break executing of kubectl commands. So in order to work with v1 beta 1, you have to update your CLI version. I will not talk about specific version, just what are the issue we hit and what our approach was to resolve them. If you are looking at the documentation, and maybe you even can invent a better solution than us. But uh, as I already mentioned, I haven't found such an information in YouTube, and I don't expect much people to look at that video, but we will check that. Um, yeah, another thing is the AMI filter name, which was already removed. So what is this? When you are replacing your worker nodes and draining them for some reason, we were looking at our AMI name, which was the AMI AMI name of the image which we were using for the worker nodes. Currently, this is removed, and to save time, we decided to take the approach to switch to AMI IDs, which are different per region, but same per environment. So we just have to configure uh, the IDs for our both environments, and everything was fine there. I don't think it was a huge issue. Um, but if you are using also the worker AMI filter, it's an issue that you have to resolve. Uh, One step back regarding C groups, the security groups, no C groups, sorry, was that when you have a second security group attached to your worker nodes, automatically by the module, you have assigned a second IP address to the node. We don't want to do that because our load balancer health checks and target groups was unhealthy because of that, and it took a lot of time to check that. And when we dig into the module, we saw that IP address per machine is controlled by how many security groups you have attached to that machine. So that was another reason we wanted to stop that from the module. And finally, we came with a lot of things stopped from the module and managing ourselves. But finally, we had a working cluster. We'll see how the things will go in the time. Um, let's see if I missed something. Nope, I think that was everything I took a note. Sure, there were a lot of other issues we faced, but I just made my first try with that video, and I think it's not so bad one. Uh, so if you are interested, or if you are interested, or I see that the second part would be useful for someone, I will create it. Actually, I have to prepare my speech for the next week, so it would be a huge one, and I will be prepared for the second video. Thanks for your time. If you reach the end of this video and if you like it, please hit the like button. Bye.